Hello again, everybody. This is the start of chapter 3 for us. So, got a couple of announcements I probably mentioned in class, but I am skipping 3.1. You might want to go look at 3.1 and review it if it will help you. It should be stuff you've seen before, but if you need a little refresher on the basics of where we're starting here in 3.2, you might do some of that on your own. That covered graphing inequalities, and I will talk through that as we go through the examples here where they ask us to graph, and hopefully you can pick up anything you don't understand if you don't remember how to do that. But because of time and things, we need to just pick up here. We're actually going to combine 3.2 and 3.3 together here, so we've got a lot to do, but it's all stuff we should be able to roll through fairly quickly, I hope. These notes should be in front of you. Hopefully you picked them up in class. If not, they should be on my website. Inequality symbols, quick review here for you. When you have the phrase less than or fewer than, that's inequality goes this way, review for you. Greater than or more than is this right here. All right, and this one you may not be as familiar with, but you should recognize it at least. If you have less than or equal to, the symbol is like that with a line. Another way you can say that is at most, like let's say I have at most $10, means I might have 9, I might have 8. I could have less, or I could have at most 10. I could actually have 10. The same phrasing with as much as or no more than. I have no more than 10. I could have less than 10. So the phrasing here, you're going to be expected to identify which of these symbols to use. If you have the symbol going this way, greater than or equal to, at least, if I have at least $10, that means I might have more. I could have 11, I could have 12, or the same thing with no less than or as little as. So get familiar with those quickly, and hopefully we can roll on. With that information, you can recognize it when it comes up to you. Equivalent, those are just two expressions that are equal, basically, right there, equal. Okay, moving on down the road here. Equivalent inequalities are inequalities that have the same solutions, and this says to write an inequality that is equivalent to the inequality that is given. So on your paper, I believe that's blank. Essentially what you have here is you have 10 is greater than or equal to -3. Then if they switch the 3 and the 10 around, well then you have to flip the sign around because -3 is less than or equal to 10. Likewise, number 3 here, if 7 is -7, sorry, is less than -1, then if you flip it around, you put the -1 first. Oops, here I meant to draw an arrow to the -1. -1 is greater than -7. Okay, so they're the same inequalities, so that's an equivalent. Those are equivalent inequalities because they're the same thing. They just reverse the sign around. So you could probably fill in 4 and 5 there, and not have any trouble there, I hope. Number 6, it says cross out the equations that are not equivalent to x is 3. Well, you're not going to cross that one out because obviously 3 is x, but x is 1/3. Well, what you're thinking there, is this a true statement? 3 equals 1/3? No, it's not. That's why they crossed that one out. 3 plus 2 would give me 5, so that one you're not going to cross out. And this one, looks like it's x plus 2, 3 plus 2. It's hard for me to read here because mine's crossed off, equals 5 minus 2. No, because that one's 5 and that one's actually 3, so those aren't equal either. And if you did the same thing down here, x is less than or equal to 3. It says cross out the ones that are not equivalent to x is less than or equal to 3. Well, that means x could be 3, x could be 2, x could be 1, it could be any number less than. So could x be 3 or 2 or 1 in this one? Sure, it could. X is less than or equal to 3. Well, if I picked the value of 3, that one would not be a solution, so you can't use it. Okay, it would have to be true of all the solutions there. even though some of the values of x might fit into that, all of them don't, so we can't really consider that a solution for us. And then the same thing is true there. If you can find one that doesn't work there, x plus 2 is greater than or equal to 5. Well, 3 works, right? 3 plus 2 would equal 5, but what if I used 2? 2 plus 2 is 4, and that is not greater than or equal to. So you can't count it because, again, all the values in that x is less than or equal to 3 would have to be true, and the same thing happens in this one, so we would cross it off as well. Okie doke. Rolling on to the next page here. Key concept here. All right, so here we go. Addition and subtraction properties of inequalities. Well, here's what they're trying to tell you here. If you add or subtract a number to each side of an inequality, the relationship between the sides doesn't change. Let me put it to you like this before we get into this. Let's just say I have 3 is less than 5. Okay, that's a true statement. Yes? Yes, it is. So what they're saying here, if I add the same number to both sides like this, now this should be in your notes because I'm showing you how this works. I'm writing it down, you write it down. If I add the same number to both sides, watch what happens. That would give me 5. That would give me 7. Okay, what symbol would go in there? Less than or greater than? The sign doesn't change. Okay, so that's what they're trying to tell you here. If you add or subtract the same number to both sides of an inequality, that sign won't change. Okay, so you're just going to solve that equation as though it were an equal sign if you're adding or subtracting. Like, look at here, 3 is greater than -1, so they added 5 to both sides, and the sign wouldn't change. Okay, because here you'd have 8, here you'd have 4, 8 is greater than 4. So that's what they're doing here in these examples here. They're just showing you if you were to have z is greater than 8, if you were to subtract -4, you could do that to both sides without changing that inequality. That's all they're really trying to tell you there. Okay, I think I explained it better, but that's the point. So then it says, as we move down to this, we can apply that property of addition to solving an equation, like n minus 5 is less than or -3. And then it says graph the solutions, and that's where I'll teach you how to graph it, hopefully, if you don't remember how. So if I have n minus 5, all you have to, what you're thinking here, even though recognize there's an inequality here, but you're really just thinking here, n minus 5, okay, equals -3. And you just follow the same steps. So we would add 5 to both sides. Okay, we add 5 to both sides, we get n is less than 2. Notice the sign doesn't change. Okay, so here it says graph. Now, I want to do that. I want to try doing that before we just circle the answer here, because you're going to have to do this for me without a multiple choice. So I want to kind of show you how it would work here. Here's what I'd like you to do. You draw a number line. Okay, I like to put 0 down. It kind of gives me a starting point, a boundary, if you will. And then notice the solution is n is less than 2. So what I like to do, if you're not given a number line, is to put down that number where the boundary is, 2, and also put down the opposite, -2. Okay, so now here's the wild thing. Okay, we're talking about all numbers that are less than 2. So like consider, is the number 2, is 2 a solution to this? Ask yourself that question. Is 2 a solution to 2 less than 2? No, it's not. However, it's a boundary point. Okay, so let me come back to that. How about, let's say 1. Is 1 a solution? Yes, because 1 is less than 2. So I do actually have a solution here at 1. How about 0? Is 0 a solution? Yeah, 0 would be a solution. How about -2? Yeah, that would be a solution as well. So basically, what about 1.5? Craziness. 1.5 is a solution. How about 1.6? How about 1.7? 1.8? Do you get my point? So basically, all of these values are solutions up until I hit 2. So I'm going to put a circle onto open. That's an open circle, and I'm going to draw an arrow this way. Because basically this arrow represents all solutions that are less than 2, and that's how you graph. Now it's important, I didn't draw it very well, but that is an open circle. It's open because 2 is not a solution. Okay, and that's important that you understand. If it were a solution, if it had the equal sign, I would have done a solid dot there because 2 would be a solution. All right, and that's basically how we graph. So this is the one that you would circle for you. So I'm a little over my time, so I better stop this, and I'll start video 2 here shortly, and we'll talk soon.